to the time, but I'm actually absolutely excited to do the presentation for 60 years of AI. I'll do a brief personal introduction first. My name is Jan, and I write on Medium predominantly to publish technical articles on cloud computing, on AI, on a lot of stuff on programming, a lot of technology. And the reason I write on Medium is that I found the amount of good, solid publications out there isn't very, very present, I might say. So the reason I started writing on Medium was because when I was young, when I started programming around like when I was 12 years old, and then professionally started when I was 17, there were a lot of magazines here in Germany all around programming that covered in-depth technical descriptions that were very, very technically focused, and that did a lot of code publication, if you will. So I really liked these magazines, and over time, as you know, the kind of publishing industry struggled, and then fewer magazines were published. Those that were published were, from my personal taste, diminishing in quality. So I remember when I was like, I think I was 16 or 17, I read articles that I had to read twice or three times in a row to be able to understand what they are about. So that's the reason why I write on Medium, is to publish articles that hopefully start a thought process in people. So I always try to be, my articles are all just purely technically focused, and this session is also purely like focused on the topic, no political aspects, etc. Because that's kind of my personal taste, and the reason why I write is I miss in-depth technical things on the internet, and especially professional publications. So I hope this one matches your taste. You can follow me. I'm not going to do too much advertising. You can see my username handle there as well. And the reason I did this presentation is because there's a lot of buzz around AI out there on the internet, on Medium, on all kind of publishing platforms. And it's a buzzword as much as all the stuff we've seen before. With cloud computing, with the internet, with mobile app development, every 2 to 3 years we have a new big buzzword on the horizon, new big topic that everybody is talking about. Yet those of you who are into software engineering or technology in general, computer science, know that these things, including AI, they don't just disappear or they don't just appear out of nowhere. So, and that's why I wanted to emphasize, what I wanted to emphasize with this presentation is that it's 60 years of AI. And if I flip to the next one in a second, you'll see it's more than 60 years. And that's why I wanted to do the presentation, is so that we look into, okay, where has AI come from? What was the original intention, or is still the intention of AI? How did it kind of move in different directions, that kind of field of computer science? And where is it heading, and why is it not as brutal as many people may think? And this is what this session is about. It's really about the history of AI. Where did it come from? Why do we have it? And what's it good for? So let's just jump right into it. The fuss about AI or humanoid robots, and robots not just being like metal humans, but robots in terms of humanoid machines. So the whole story started 100 years ago already. So the Czech writer Karel Čapek phrased the term robot in 1920, so over 100 years ago. And that was when first in popular writing and publications and literature, the word robot appeared. So, and then two important other important publications. There was the book The Metal Giants that featured Martian robots in 1926. But that one publication or piece of art that most people in artificial intelligence refer to is the German movie Metropolis from 1927 or 1928, depending on what you consider release. Is a movie about a future where it's a dystopian science fiction about a city where people are essentially controlled by robots. It's a silent movie, meaning there's no talks in there, and the movie is actually about this weird scientist building robots to control the population, and there's social critique in there. There's technology critique in there, which is very interesting. The movie itself is hard to digest. I'm just not used to silent movies, but it's one of the first appearances where we as human beings, as societies, fantasized about having humanoid robots or humanoid computer systems or machines. I should probably rather say machines. So 100 years ago, roughly 100 years ago, um, we human beings fantasized about having humanoid machine counterparts, if you will. So that's where the whole idea in our society about machines that are like human beings, that's kind of where it started. So that's 100 years ago is when the whole idea about artificial or humanoid machines started. And then that was, of course, way before human beings or computers in the form that we know them today actually existed. So that's kind of way before our time, our time of computing. So, and a lot of years have passed by since then, and we had World War II, which saw tabulating machines in utilized in the worst way possible. So that was kind of the steps computing took. And of course, artificial intelligence, talking about human machines, is something that requires computers, right? So without computers, you can't have artificial intelligence. That's the whole idea behind it. And what is considered the birthplace of AI is actually the Dartmouth Conference. So the Dartmouth Conference in 1956 was when people met. We had three or four people from different universities in the United States. It happened in Hanover, New Hampshire. So not the Hanover in Germany, but the Hanover, New Hampshire. And it was a workshop to bring together the different universities that already did research on artificial intelligence, which was the MIT, a couple of other universities. And that's usually considered the birthplace of artificial intelligence in terms of really making it a scientific field of research. So they got together in July 1956, and I want you to remember July 1956. We'll talk about it next time. And they decided what artificial intelligence is and what the aim of research in artificial intelligence shall be. So during that workshop, they did not just coin the phrase artificial intelligence, but they also described it as being a field of creating machines that simulate human intelligence and replicate human cognitive abilities. So essentially, machines that are able to do what your brain can do. That's kind of the basic idea of what artificial intelligence is supposed to be. And that's a very noble aim or idea, but yet also an extremely complicated one. If you look at this, it's 1956. They haven't been on the moon. They don't have home computers. Phones are relatively new. They don't have wireless phones. Computers are the size of entire like storage facilities, and yet these guys have the idea to kind of replicate the capabilities of the human brain. So really, really complicated things that I want to achieve. And then concepts that they derived out of that idea is logic and symbol manipulation. I'm not going too much into detail. General problem solver, so systems or software that can generally solve general problems, machine learning and adaptation, language translation and understanding, which is an important part. We'll get to that in a bit. So that's kind of what they wanted to do. And you see the images on the right hand side. A nice little conference. They got together and did that. All these gentlemen. I haven't seen a single woman. So, and let's imagine that I said it's important, and I'll just put myself to the side, so I'm not going to disturb any images. So, July 1956 happened to be also the month when Carol Morris was crowned Miss USA 1956 and later became Miss Universe. The reason I added her image is for you to be able to grasp what their idea is of AI. So artificial intelligence aims to replicate human intelligence. So everything, in a mathematical way, which means that everything humans do would be traceable with calculations. So, or how shall I should phrase this differently? You would be able to mathematically explain any human behavior. So in July 1956, Miss Morris decided to enter the contest to become Miss USA in 1956. A couple of other human beings then also voted for her, so she became Miss USA. So, and now artificial intelligence is the approach that you could mathematically explain how she became Miss USA 1956. So the kind of the entire human thought process, that's what it is about, right? So artificial intelligence is not about the mechanics of moving fingers and arms and all of that. That's robotics. That's robotics, and that's physics, and that's kind of solved almost entirely with a few fields still to explore. But artificial intelligence is about mathematically explaining the mind and thinking. Yeah, the 1960s, always 50s and 60s, if you look up TV shows about AI, they talk about mathematically explaining the thinking process. So what's currently going on in our head, what was going on in Miss Morris' head, and to replicate human intelligence. Well, to replicate human intelligence, we first need to think about what is human intelligence. Human intelligence is scientifically defined as acquiring, comprehending, and applying knowledge. So that's kind of learning, right? On your own, without being instructed. Ability to acquire knowledge. So you go to, you know where you acquire them, you read stuff online, you buy a book, whatsoever. So that's acquiring the knowledge. Comprehending, understanding the knowledge, what it is about, being able to acquire additional knowledge if you need knowledge, then use this, apply this knowledge, meaning you use this knowledge to solve complex problems and reason logically, right? Logically. Adapt to changing environments. Well, Ms. Morris that's quite some years ago that she became a Miss USA, and the world has changed drastically since. So human intelligence means you're able to adapt to a changing environment. And then an important one, exhibit creativity and abstract thinking. So you're not just able to acquire knowledge and apply knowledge, but you're also able to creatively create solutions or creatively create something. Yeah, without being instructed on what to do, where to do, when to do. So if you're being dumped somewhere, either on an island or somewhere different. As a human being, because of your human intelligence, you're able to navigate your way. You're able to learn a new language if you're in a region that speaks a different language. You're able to learn the culture, get around with people, etc. So your survival instincts as a human being, the knowledge that is baked or programmed into your brain when you were born, plus the knowledge you acquired when you grew up, that's in your brain. So that's kind of what artificial intelligence wants to replicate as well. Then engage in effective communication so human beings are able to effectively communicate with each other, which means, I'll just quickly move my image back in the other corner. So, which means that if you would have met Miss Morris, you would be able to have a conversation with her. How are you doing? What brought you to this contest, etc., etc. So, an artificial intelligence would have to be able to communicate with a human being in an effective way so that it doesn't negatively affect the other human being. And then the most important part, and that's my absolute favorite, we'll get back to it on the last slide as well, demonstrate emotional awareness and social interaction. Well, that's kind of what a human intelligence is, right? So you go to go somewhere, be it a conference or a bar or a club, you socially interact with other people. Yeah, some people do that more than others, but you socially interact with other people. So, and that is something, and all of that, and what I'm showing here is that's what AI wants to replicate. Yeah, we'll go into the different fields of AI in a bit, but that's kind of what AI wants to replicate, right? The whole thing. It wants to the aim of artificial intelligence, and let that sink in, is to replicate the entire Carol Morris. That's kind of the idea. Replicate the whole human being. So that's what they want to be able. And the idea behind it is to say, well, human thinking and the entire like human system as a biological system is entirely mathematically explainable. So that's kind of the idea. So that, and that's the goal of AI as defined during its birth. Yeah, and how did they get there? Well, the first few baby steps. I'll put myself in the other corner as well. There you go. Okay, so the entire idea of that then had to be put into reality, right? So and with these old, you'll see some IBM 360s on these images. Well, that's a tough challenge to replicate the whole Carol Morris or any human being with tape recorders, right? So that sounds silly in our modern world, but even our modern world isn't able to replicate the whole thing. So the first few things were baby steps. The logic theorist, if you're interested in, read about it, is used automated reasoning to prove mathematical theorems, which for a computer, which is essentially a massive calculator, not a problem. Yes, very smart algorithms. You shouldn't underestimate the effort and work they've put into building all these systems, but it's light years away from replicating human intelligence. Yet for solving mathematical theorems, very good results. I mean, outstanding results, better than the authors of the software imagined. Then we had one in 1966. ELIZA is often coined the first chatbot, but it's a simulated conversational system. There are versions online that you can test in the browser. You'll be absolutely underwhelmed of how it works. It's not really that exciting. It's not really that exciting. I can tell you that. So, but it was a first approach into what we today consider chatbots, or kind of you would say it's the great grandfather of ChatGPT. Now, I would say Eliza is it's a woman. She was female, so she was the great, or is the great grandmother of ChatGPT, if you will. Then we had the expert systems. I have books about endless books about expert systems. What are expert systems? The definitions vary a bit, but in essence, these are systems that emulate human expertise. By today's standards, we would not necessarily consider them artificial intelligence because they're rule-based systems in essence. So an expert system is, for example, an airline ticketing system where you buy tickets, goes into a database, it decides on whether ticket is valid, et cetera, et cetera. That's considered an expert system already. So, and that was kind of the 70s were really about in social, technically, the 70s were the age of the mainframe, large mainframe computers, large business systems and technology, airline reservation systems, hotel reservation systems, financial accounting systems. The banks moved from paper to machines a big time. So all these organizations, government and industry and businesses moved to mainframes if they were large enough to pay for these huge machines. That happened in the 70s. And that movement had nothing really related to AI, except if you really define any expert system as artificial intelligence. So, but what happened in the 70s was there were a lot of discussions about the impact of computer systems on society. And one example, I have a ton more of German examples, but one example is the book Shockwave Rider from 1975, which is a critique on technology and the way it works. It's science fiction, but very similar to what Metropolis already, the issues Metropolis already mentioned. So that's kind of the 70s, a difficult era. And there is, you probably would expect me to talk about the two AI winters, which I'll not talk about, which were periods claimed to be that, where it was claimed that research funding was reduced and there was not much progress in AI. Well, given that progress in computer technology happened exactly during that time, 70s, 80s, yes, there was some progress in AI, but looking at the amount of resources you need to run these algorithms, you can imagine that it's quite tough to do that in the 70s and 80s. Now, jumping forward a little to the 80s and 90s and onwards. What actually happened with AI? We had a ton of algorithms focusing around neural networks. Back propagation in 1986 was very popular to train neural networks. We had in 97 Deep Blue beating Kasparov in chess. Which was a remarkable moment. Yeah, I mean, for AI development, board games were AI for board games was as early as in the 1960s, where they trained computers to do board games. I think the first few were chess was among the first few, plus a few others. Agent software became popular in the late 90s, although, I mean, that's the kind of classic chatbot. The whole chatbot thing, from Eliza to these e-commerce agents in the late 90s up until ChatGPT, that's kind of, that's a clear line that kind of goes through the entire development of AI or artificial intelligence. Computer vision entered the automobiles in the early 2000s. That was when camera technology became mobile, became digital. That is when the first experiments with computer vision in especially real-time computer vision started, so that systems are able to see really the environment around them. IBM Via Voice was popular in the 90s, but the most remarkable natural language processing in the AI field was MaxSpeak when the Macintosh was released. If you're interested in, I highly recommend watch the Macintosh presentation where the Macintosh speaks itself, or it was recorded, but I have the Macintosh here and it can speak. So I've got the 1980s AI technology installed. It would say, never trust a computer you can't lift. And that was speech, synthesized speech. So then Google Translate came in the early 2000s and proves the natural language understanding capabilities. Recommender engines if we're talking about AI, we're talking very little about recommender engines. And that's really, really bad because recommender engines make up the majority of AI deployments we have today. So Amazon's people who bought this are also interested in this. You may also like that. Emails, targeted advertising, those are all recommender engines. And recommender engines are the machine learning. It's part of it's machine learning in the AI sector. Recommender engines are machine learning systems that have been deployed out in the wild for the longest period. So, and they are search engine, Facebook, Amazon, Apple, Google. That's all recommender engines actually. So, and the problem is that some people have understood, or we as a society think there is a problem technically with recommender engines on around how they function, like if they advertise certain products, etc. And we are kind of identified seems to be a problem. I can tell you the deployment of recommender engines that I've seen is the majority of them just runs on their own, and it's wild. It's wild, absolutely wild. If you see on the treatment that recommender engines get by the companies that deploy them, it's wild. You think they're probably properly trained, and they have their data and their results are being reviewed. I can tell you that's not the case. Most companies that deploy recommender engines, where they have recommended listings, etc., it's just wild. They don't themselves know how these systems work. So recommender engine is something I'll go into on the last slide as well. So what essentially happens and out in the commercial world, yes, there's the research part where a lot of work is still being done, and I'll also focus on some things later on in terms of where research is not really being done at the moment. But essentially, if then that algorithms were replaced by the well-known algorithms like the KNN nearest neighbor, the k-means, it's a lot of recommender engines and always the same algorithms in many practical applications today. So what's the current state of AI is we're focusing a lot on machine learning, natural language processing, and computer vision. So we're trying to get the machine to view, to hear, to speak, and to generate thoughts. So that's kind of natural language generation, LLG, and that's generative AI, and that's pretty much what ChatGPT does as well. Natural language understanding is understanding what someone says. That's pretty much what Siri does. Text to speech and speech to text used to be super bad in the mid 90s, but it's become really, really good. And then we have the classification and general learning things. That's where the recommender engines fall into. And then we have computer vision, making the computer see things. So that's all kind of giving the computer senses, right? It's not really the computer thinking or doing anything very special. It's the computer giving him senses. So a natural language generation or generative AI with diffusion or stable diffusion, I think the algorithm of ChatGPT is called stable diffusion, is nothing else than combining a lot of information, then smashing it all together and trying to produce something that makes sense and withstands some basic tests. And there is a great video from the computer file on YouTube, if you like that, about how generative AI and image generation works and text generation works the same way. You take a lot of things, you smash them all together, try to make sense of them, compress them, and then just provide some information. And that all works with probabilities. So that means a lot of the stuff you see in AI is a result of probability. It's a result of probability. So, and it's not in no way replicating human things. So AI models today are awesome. They're great. I love them. I use them myself a lot for a variety of different things. I love computer vision. It's great that we finally have the compute power to detect things and let the computer see. I love generative AI because it's fantastic to let the computer actually express something out of structured data. That's fantastic. Natural language understanding is great. No longer do people have to use complex user interface. They can just say what they want. However, the problem is the best AI in the world, or the best generative AI, cannot, and if has the problem that if a user comes and says, I want to make $100,000 a month without actually working or doing anything, well, no AI in the world can do that. So the problem is they still can't think. Yeah, there's comments, and I listed some parts of AI research and AI that aren't currently in the hotspot. So common sense reasoning, yeah, making decisions out of common sense information or data is something that they still can't do. AI models still can't. We don't have a common sense reasoning AI model out there in the wild. Not available. They aren't even remotely humanoid. It's all mathematics, it's all probabilities, it's calculations. So the algorithms that drive AI are all probability. Yeah, it's got nothing to do, absolutely nothing to do with how a human works. So there, the cognitive functionality of our human brains is entirely different to these AI models. So it's nothing related. But cognitive architectures is a field in AI that aims to reproduce the human brain. And that's also a field we rarely talk about. It's just all microprocessors and text generation. And everybody screams out, taking my job, which is not going to happen. The models are interculturally unaware and totally biased. They're based on the training data that they get, and they can only have a very limited set of training data. And that's a massive problem in these in generative AI, which is essentially just diffusing all these kind of contents and source information that they have and recompiling them to something. Is that if the source information is biased or interculturally unaware, well, of course, the compiled result will be. So that's a big problem of these generative AI, because we think it's a smart or thinking system that, or even a researching system, yet it takes information, it takes probabilities based on what it has, and then just compiled something new. So it's not remotely creative. And you saw on the slide with our Miss USA that being creative and able to create something new, that's a human intelligence. But even ChatGPT is not even remotely there, because it just recompiles and tries to make useful sentences out of it. So, and then the most important part, and that's kind of the kicker why we won't have really AI for the foreseeable future, like a general, it's called general AI, strong AI, full AI, whatever you call it. Effective computing is the part of artificial intelligence that works with understanding, recognizing, and responding to human emotions. The problem is we don't have any models that can do that. We have facial analysis that can kind of identify emotions. The speech recognition is getting there. So it's getting there if you're afraid or happy or annoyed or bothered or not concentrated. We're getting there to have systems to be able to recognize that. Yeah, but recognize is the smallest part. That's not understanding and responding to it, and using common sense reasoning on how to communicate with someone who's sad. And those are the kind of four sectors in AI totally unexplored. Common sense reasoning, cognitive architectures, fighting bias and racism and growing cultural awareness in these systems, and emotional competence, especially effective computing. And those are the bits and pieces. And if you look back on what I initially said about what AI wants to achieve, replicating human intelligence, then I would say we're probably on the road to replicating human intelligence, but probably at 10%. Even if you argue that ChatGPT and that the human intelligence is essentially just taking a lot of information, compiling them together and repeating them, Well, you would have a long discussion with cognitive, with neuroscience on this approach. So I think, yeah, ChatGPT probably got us through the 15 or 20% barrier, but that's where we currently stand. And that's the history of AI. It's a very short history. It's not too much that happened. And if you look at the algorithms, and anyone who's tech savvy, I highly recommend get your general understanding of what these algorithms are. What is KNN? How does it work? The nearest neighbor. What is K-means? How does it work? What other algorithms are being used for artificial intelligence or machine learning? And then what are their limitations actually? So, and that's kind of my recommendation. And that's my session about humanoid in human intelligence or artificial intelligence, how to replicate it. If you're interested, feel free to ask questions in the QA. I'll stick around here for a few more minutes. And then we can go through, I can go through some questions if there are. Let's see if there are some questions. Yeah, I opened the QA, so if you have any questions, feel free to let me know. Danke, Lutz. Grüße zurück. Thank you, Lutz. What do you think the next logical phase of AI is? Well, the next logical phase is just the continuation of development. So look at the problem we had with compute. We have Moore's law that like compute power, performance, and capacity increases like x-fold every few years. But the growth in compute power is slightly in decline, and that's why so many people bet on Nvidia that their chips show massively higher compute performance, especially for AI. So with the next steps in compute performance, we will be able to do more complex algorithms and even more of them. So in terms of new algorithms, I wouldn't expect too much, but compute performance will become more and more available. Due to the general attention that AI currently receives, we will see more in common sense reasoning, more algorithms. We will definitely see more in cognitive architectures. You hear a lot of people talking about implementing chips into humans and stuff like that. So that's something we'll see far more often in the future, because that's AI. Actually, my personal opinion, I think the end result of AI is the human brain itself, right? So if you look at what happens in the medical field and what happens in technology and biotechnology, and that will find its way together. So the problem is, if you want to replicate human intelligence, you need to first understand human intelligence, and we don't know how the brain works entirely, right? So if you ask, if I throw this pen on the ground here, and I would go to a mathematician and ask, why did I throw? What happened in my brain so that I made this pen fall down on the table? He couldn't answer that, and that's the actual problem and the challenge is that in order to be able to replicate the human intelligence, you must first understand it, and we don't understand it yet. So I think biotechnology is coming. How do people in rural How do people in rural areas possibly benefit or even participate? How do we make sure that AI awareness extends to civil societies? Well, through media and through a lot of publication. Oh, give me a second. Yeah, and that's the adoption curve. So every new technology has an adoption curve. You have the early adopters, and then you have the majority, and then you have the laggards that come and pass in rural areas. Sometimes it depends on where you are the laggards in AI. So I think that's a challenge for a society to think about how everybody's being kept on board. So but it seems as a lot of companies are racing to integrate their existing products with AI. So is this premature? I would say no, because as I said on my previous slides and with Schwarzenegger, probably a bit too fast. Usually in programming, the initial way we program software is that we wrote algorithms like if this, then this, and then this, and then this, and became more complex. And we have multi-threading and multiple CPUs and distributed systems, all of that. So I'll give you a practical example so you can really see kind of what I'm talking about. So if someone comes to a website, you know that person is from, let's say, the person is from Boston, right? So a person from Boston comes into your website. So beforehand, you would give them an option list and say, okay, what would you like to have? Like, let's say it's a food ordering service or any e-commerce software, and then ask what product category are you interested in? Now that's one way that's a kind of traditional approach, right? User selects something. With the statistical power that we have in the machine learning software is that we can make predictions on what people actually want. And not just people, we can also make predictions what systems, what will actually happen here and there. So that's it makes absolute sense for businesses to incorporate machine learning because it will help them make the product better. That's very, very simple. So if they're going for AI, yes, they're often going to satisfy their shareholders. But if you look at it from a programming perspective, the way you program and default, especially if from a programmer's perspective or software engineering perspective, if you think about default values, the default values you have in their software are often the common minimum that works, right? So that where you know this works on everything. Well, if you have a machine learning algorithm where you can say, okay, I'm in this environment and that is here, and the probability that this value will work better than that is that and that percent. So it makes sense. It's a different way of programming because you're not just working with fixed rules that you implement in the form of static algorithms, but you're working with probability. And I think that's the most important part that changes for us software developers. If I talk about us software developers, since I write a lot of articles on software development. So I think that's the most important part for us software developers and software engineers and programmers is to understand we're not just living in a rule-based world, we're living in a world where we need to use these algorithms to use probabilities in uncertain scenarios. Okay, I think that's everything in Q&A so far. And that I'll mark some as answered. Yep, mark as answered. Good. Thank you everybody for joining in. And if you the fun thing, if you still have questions or want anything from me, I'm here on Medium. And you'll also find me with the same handle. You'll find me on Twitter, on LinkedIn, anywhere. So if you have any questions you want to connect on LinkedIn or Twitter or Facebook, I rarely use, to be honest. Instagram, if you want to, feel free, give me a buzz, follow me, connect, and stay in touch. Yeah, so since there are no new questions, thank you everybody for joining, and enjoy the rest of Medium Day. Have a great evening. Bye.